In problem 711, you're asked to find I naught for t greater than 0, and I naught is going to be this current through here, which happens to flow through the 4 Henry inductor and the 8 ohm resistor branch. You're also told that this switch T opens at t equals 0. And so what we'll realize is we want to first of all figure out what our initial conditions are, based upon assuming that prior to this switch opening, the circuit was in steady state. And in steady state, the inductor behaves like a short, so we replace that there. And then we've gone about analyzing this circuit here. You can figure out the voltage across the 8 ohm resistor over here by finding the parallel equivalent of the 8 ohm and the 4 ohm resistor, and then realizing this is a voltage divider and can be solved. And so, if we go down here, we figure out the parallel equivalent is 8 over 3 ohms, and then the voltage across that pair of resistors is 9.6 volts. And so now to figure out the initial current through this 8 ohm resistor, we take our 9.6 volts that are across it to begin with, divide it by 8 ohms, and we just get an initial current of 1.2 amps. We also know that is the current flowing through an inductor, so even though we determined I naught of 0 minus, that will also be I naught of 0 plus. So that is our initial current through the inductor. Now, after the switch opens, the circuit behaves like a source-free RL circuit. And so in this case, we can model this by the equation I naught of t equals the initial current times e to the negative t over tau. And tau for an RL circuit is going to be L over R, and in this case R is going to be the equivalent of 8 ohms in series with 4 ohms, or 12 ohms. L is 4 henries, so our time constant tau is 1/3 seconds. And our initial condition, as we already found, was 1.2 amps. So I naught of t is going to equal 1.2 e to the negative t over tau, which gives us negative 3t amps.